Okay, we have to determine whether this series is absolutely convergent or conditionally convergent. So first we're going to determine if it's absolutely convergent. Absolute convergence implies convergence. But if we find out that it diverges when we're checking for absolute convergence, then we still have to check for conditional convergence or for divergence. Okay, so the series that we have, a sub n, is going to be absolutely convergent, with a sub n as a sequence in a series, is going to be absolutely convergent if this converges. So let's try to find out if that converges. What is that going to be? This is going to be whatever we get when we plug in our a sub n, which would be -1 to the power of n over n cubed plus 1. The -1 to the power of n goes away with using the power of the absolute values, using the behavior of the absolute values. So now we have that. Now we have to check for convergence or divergence. So we could use any test that we want. The one that I would use is a comparison, just a simple comparison test in which we would have this compared to this, where we have n cubed in the denominator. We would have n cubed, and n cubed is obviously by the p series, 3 being greater than 1, this is going to converge. This is going to converge by the p series. So we know that. And since this one is less, because you have a greater denominator, so therefore this series is less than this one, it must also converge. So since we've proved that this converges, and we're doing the absolute value test, then it absolutely converges.